Welcome back to Burton Math Unlocked. Today we're going to be going over the Algebra 1 Regents from June of 2026. So it's been recently posted. So we're just going to go over some of the questions so you know what to expect on any other previous Regents or any of the new Regents coming up. So we're going to start with part 1, which is all multiple choice, which can be done in pencil and or pen, your choice. They do give you a section to show your work. I highly recommend showing your work. It's a lot easier to notice what is happening and occurring if the work is shown. So with question 1, we have what is the 20th term of the arithmetic sequence? 4, 7, 10, 13. Because it states that it's arithmetic, we know that our sequence is either going to be adding or subtracting. And as we can notice is that we're increasing each time by 3. So 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, and continues on. We want to figure out what the 20th term is that is occurring within this sequence. And in order to do so, there's 2 different ways we can do it. So we can be the person who likes to write out all 20 terms by just adding 3 each time until you get to, or we can use our formula that's on the reference sheet. We're given our arithmetic sequence formula on the reference sheet, which is a of n equals 1 plus n minus 1 times d, where n is the value that we're trying to find. So since we're trying to find the 20th term, we will place that in for n. So n equals 20. The other variable that we know would be a of 1, which would be our first term. So a of 1 equals 4. That's the first term given to us. And then from here, we need to figure out what that difference is. And we know that we were adding by 3, so that difference is 3. So d equals 3. Now all we have to do is plug these values into our formula to solve for the 20th term. So our formula now turns into a of 20 because n equals 20. And then a of 1 we said was 4 plus, once again, n is 20 minus 1 times 3. Once we do that now, all we have to do, you can put this into your calculator and simplify, or we can simplify it together. For the sake of time, I lied. For the sake of being mathematicians, we're going to solve it together. So 4 plus 20 minus 1, so 19 times 3. 19 times 3 simplifies to 57. So now we have 4 plus 57. And then 4 plus 57 gets us to 61. So a 20 equals 61. So our correct answer here would be answer choice 1. Sorry, not answer choice 1. Yeah, answer choice 1. Be careful not to use multiplication, subtraction, or division. It's a lot easier if it tells you if it's arithmetic or geometric. If it's geometric, that means we're either multiplying or dividing. Arithmetic means that we're adding or subtracting. And like I said, you could also write out each of the terms. So if we know we have 4, 7, 13, that's 4 terms. And we can just count up to the 20th. So 5, 6, 7, 8, 9, 10, 11, 12, and keep going, 13, 14, 15, 16, 17, 18, 19, 20. So 13 plus 3 is 16, and keep going from there. So then 16 plus 3 is 19, 19 plus 3 is 22, 22 plus 3 is 25, 25 plus 3 is 28, 28 plus 3 is 31, 34, 37, 40, 43, 46, 49, 52, 55, 58, 61, which gets us our 20th term. Okay, moving on to question 2. So what is the value of x in the equation of 5/10 x minus 4 equals 8 minus x? So here, we can do it a multitude of ways. If you're somebody who's not strong with simplifying and isolating variables, you can plug in each of the answer choices and substitute them. So for example, if we have answer choice 1, which is 6, we're going to plug in / substitute 6 for x. So instead, we will do 0.5 times 6, always put in parentheses, minus 4 equals 8 minus 6. You can do that with the rest as well and see if both sides simplify to the same value. So half of 6 is 3, minus 4 is negative 1, and 8 minus 6 is 4, which means that those two do not simplify to the same value. Next up, we have 0.5 times 8 minus 4 equals 8 minus 8. 8 minus 8 is 0. And then we have half of 8, which is 4, minus 4 is 0, so 0 equals 0. So that is a possible answer. Next up, we have 0.5 times 18 minus 4 equals 8 minus 18. In this case, we have half of 18, which is 9, minus 4 is 5. And then 8 minus 18 is negative 10, which means that those two do not simplify to equal one another. And then lastly, 0.5 times 24 minus 4 equals 8 minus 24. Half of 24 is 12, minus 4 is 8, and then 8 minus 24 will not get you the value of 8. It'll be a negative number, so that can't be true either. So the correct answer here would be answer choice 2. Another way for you to solve, if you're somebody who likes to solve algebraically, we can actually combine our like terms. So I'm going to erase a little bit of what we have at top, just so we have some space. So we have 5/10 x minus 4 equals 8 minus x. When we have problems like these, we want to make sure that we get our like terms to one side. So for example, 0.5x is a like term with negative x. And remember to keep those signs in front. And then negative 4 is a like term with 8. Whatever we move to one side, the other thing we need to move to the other. So for me, I'm going to turn this into like a T-chart just to make it easier for me to organize my work. On the left side, I want my variable. And on the right side, I want my constant. And as a reminder, a constant is a number that does not have a variable. So those standalone numbers that you've been learning since the first day of time. So when you just started counting up by 0. So with that said, we want to be able to move that x to the left side so it's on the variable side, and that negative 4 to the right side so it's on the constant side. In order to move something from one side of our equal sign or the equation, we have to do the inverse operation. So the inverse of subtraction is addition. So we're going to add x to both sides and start there, which means that these two x's cancel out because equals 0. And then we have 1x, because it's imaginary 1 as a coefficient, plus 0.5. So we have 1.5x minus 4 equals 8. Now that we did that, we want to move our constant negative 4 to the other side. So we're going to do that by doing the inverse of negative 4, which would be adding 4, which means that negative 4 and positive 4 cancel out, and we are left with 1.5x equals 12. Since x is being multiplied by 1.5, we have to do the inverse of that, which would be our lovely division. So we're going to divide both sides by 1.5, which now tells us that x equals 8, which would be the answer that we chose. You can also plug it back in just to be sure with substitution, which is what we've already done. Moving on to question number 3. So we have the binomial 4x squared minus 25 is equivalent to. When we have a question like this, first of all, we want to see if there's anything that can be factored out between 4x squared and 25. 4 goes into 4 times, but 4 doesn't go into 25 equally, which also tells me that the first two answers that can cancel out is 1 and 2. Because in order to factor out that 4, we're going to be left with a fraction with that negative 25. Now we have 2x minus 5 parentheses, and then 2x plus 5 parentheses, and then 2x minus 5 parentheses, 2x minus 5 parentheses. If you've learned this rule, we know that if we have a negative times a positive, that will get us a negative product, and then if we have a negative times a negative, that will get us a positive product. So our last term, if you were to do FOIL, first, inner, outer, last, that last term is going to be negative for this one should be at negative 25, and our last term for answer choice 4 will be positive 25. In this case, we want that negative 25, so our correct answer here would be 3. Another way to do it is to use that FOIL or box method. I'm going to show it as the box method because sometimes it's better to see that visual. So in the box method for answer choice 3, we have, I'm going to do this in another color, 2x minus 5. So all we're going to do is find the area of each of these boxes and then add it all together and combine like terms. And then the second part is 2x plus 5. So 2x times 2x to get that first box is going to give us 4x squared. And then our second box, so to the right of that, is 2x times negative 5, which would be negative 10x. The box below that would be 2x times 5, which would be positive 10x. And then our last box that we have over here is 5 times negative 5, which will get us negative 25. We know that 10x and negative 10x are going to cancel out, so we're just left with 4x squared minus 25, which matches our expression that we want it to be equivalent to. So answer choice 3 would be our correct answer. For question 4, we want a function that is defined by the following set of points. What is a possible value for x? So we have 3, negative 4, negative 4, 3, 1, 1, and then x, 2. When we talk about functions, we never want our domain or our x values to repeat. So domain does not repeat. One input for every output. I personally like to make this into a t-chart once again, similar to that chart that I did above. And we're going to have our domain on one side, which would be our x values, and then our range on the other. Or you could write it as input, output, your choice. So we have 3, negative 4, 1, and then x. And then we have negative 4, 3, 1, and 2. So we already in our domain use 3, negative 4, and 1, so we can't repeat that again. So if those are any of the answer choices, we can automatically cancel that out. So we used 1, we've used 3, and we've used negative 4, which means that our last value can be that lovely 2. You can have the same input for the same output. You cannot repeat your inputs for an output. So we can't have another value being 3, negative 5, for example. Okay, moving on. We have question number 5. So the expression parentheses 4xy squared close parentheses raised to the power of 3 is equivalent to. When we have a problem like this, a lot of students tend to struggle. But since we have those parentheses, we automatically know that we need to take that 3 and distribute it to every single piece of that term. So we're going to distribute that 3 to the 4. We're going to distribute that, or the cube, to the 4, to the x, and then to the y squared. So we basically now have 4 cubed times x cubed times y squared cubed. 4 cubed is equivalent to 4 times 4 times 4. So 4 times 4 is 16, times 4 is 64. And then we multiply that by x cubed, which just simplifies to x cubed. And then when we have y squared raised to the power of an exponent, that always means that we multiply. So we're going to do y squared and then multiply that 2 by the 3. So it's basically just y raised to the power of 2 times 3, which simplifies to y raised to the power of 6. So this all simplifies down to 64x cubed times y to the power of 6, which will leave us with 3 as our correct answer. If you were to get answer choices 1 or 2, your first mistake would be multiplying 4 times 3. You have to raise 4 to the power of 3, so cube 4. That would be that first mistake. And then for answer choice 4, the mistake would be that raised to the power of 8. You got to be careful there and making sure that we're multiplying 2 times 3 instead. Okay, question 6. Allison was asked to write a third-degree trinomial, which means that our exponent should be 3. With a leading coefficient of 4. Coefficient is that number that's going to be multiplied by the variable, so it would be like 4x raised to the power of 3 is what we're looking for. And a constant term of 5. So similar to what we said in that previous problem, the constant term is that standalone number. And since just 5, it's positive 5, so we just need to add 5. Which expression satisfies these conditions? It does not state that it needs to be written in standard form. So that does not mean that the order is going to be based off the degree. We just want to make sure that we have that 4x cubed, and then we have that plus 5. So answer choice 1 is 4x cubed minus 5, which can't be true because we don't need a constant term of negative 5. For answer choice 2, also incorrect because our leading coefficient is 3 instead of 4, and our third degree trinomial has, or it's not a third degree trinomial, it's a fourth degree trinomial. Answer choice 3, we have 4x cubed, which checks off, and we have plus 5, so that's a possible answer choice, but let's just check with the last one. We have 3x to the power of 4. 3 is not supposed to be a leading coefficient, and 4 is not our leading degree, which means that answer choice 4 cannot be correct. Also, our constant term is negative instead of positive, so we will be left with answer choice 3. And it's written in standard form. Okay. Next up, question number 7. So given the sequence 128, 64, 32, which formula could be used to find the nth term of this sequence? So first, we know it is a geometric sequence. How do I know it's geometric? Because there's no way to add or subtract to get from 128 to 64, and then using that same value to get to 32. Instead, we are taking this and we're dividing by 2 each time. But when it comes to geometric sequences, we don't always want to divide. Another way of dividing by 2 would be the inverse. It would say multiplying by a half. So we want to look for our answer choices that show that we're multiplying by a half, but also using that formula that's on our reference sheet. So the formula on our reference sheet for a geometric sequence, I'll give you a moment to look at it if you don't know it already, but we're going to write that down to help us in filling out the certain parts that we need. Do you need the formula? No, you do not. So it's completely up to you on what you want to use. But the correct answer for this problem would be answer choice 2. So we want to make sure that we are multiplying by half each time. And then we also know that if we were to plug in 32 per chance, just as an example, 32 is our third term. So we can set this up as a of 3 equals 128, because that's our first term, times a half, and then raised to the power of 3 minus 1. We want this to equal 32 when we simplify it, because that is our third term. We're just proving that's our third term. So now we have 128 times 1/4, because 3 minus 1 is 2. A half raised to the power of 2 is a half times a half. So 1/2 times 1/2 is 1/4. So we have 128 times 1/4, which leads us to 32 as our final answer for our third term. Since that is true, we know that that equation would be true. Okay, question number 8. This is one that a lot of students tend to struggle with, but it can be broken down if we have like some real life scenarios. So let's start with, when a bicycle increases the pressure on the brakes, the speed of the bicycle decreases. This relationship can best be described as, so we want to think of it as ourselves. So when you're on that bicycle and you were to press those brakes, that means you're slowing down. So you're increasing the force to get yourself to a stop, even a car or any sort of vehicle, increasing that force to get something to stop. Since we have separate correlations in a sense, so since we have one of our variables being directly correlated to increasing the pressure, and then the other variable be correlated to decreasing in speed, we know that we need to have a negative correlation because we have opposite values. So we can automatically cancel out 3 and 4. Now, between a causal relationship and a non-causal relationship, a causal relationship is something that is directly caused by a change in one of the variables. So because of the fact that we decreased our speed by increasing that pressure, we know that we're going to have a causal relationship. Another example of a causal relationship would be like driving a car. So when you drive a car and if you start increasing your speed, your travel time goes down. So maybe the miles per hour on the street is 65 miles per hour. I know in New York City, it's usually 55 on the highways, 25 in the streets. The faster you go, the sooner you're going to get to your destination. So that travel time is always going to decrease. But if we were to do the opposite, and let's say there's no causal relationship, so let's say one day you see that there's a sale on umbrellas because it is a rainy season. It could be hurricane season in Florida or someplace in the South. Just because you have an umbrella does not mean that the rain is going to go away. It's just going to help protect you from the rain. So that'll be a non-causal relationship. So our correct answer here would be answer choice number 1. Next up, question numero 9. Okay, so a garden club plans to plant 40 flowering plants this year. They will only purchase daffodils that cost $4 per plant, which is a key part, and tulips that cost $5 per plant, another key part. All prices include the tax. The club has $170 to spend on plants. Which equation could be used to find the number of daffodils or daffodil plants D the club purchases? So in a case like this one, we want to use that information that's given to us. So we only have 40 flowering plants this year. So that's some important information for us to know. And within those flowering plants, we have tulips and we have daffodils. We know that it's $4 per plant. And then the tulips cost $5 per plant. So daffodils is $4. Let me put these in different colors actually. Daffodils is $4. And then the tulips are $5. So daffodils I'm going to do in green. And our tulips in red. So over on the side, so far we know we have daffodils that cost $4 per plant, and D is the value of daffodils. If we know it's $4 per means multiplication. So we're going to do 4 times D, and it usually tells us that we're adding. So we're going to add the price of the tulips, and that is going to be $5 per plant. So that's just some information we know. We know that we need to have 4D plus 5. We also know that there is a total amount of $170 to spend. We can't spend more of that, but we can spend less. And total usually means we have to equal 170. So now looking at our answers just with that information, without that black part, the part that says plant 40 flowerings, we know that we can cancel out a few of these answer choices. So we can cancel out answer choices 1 because it equals 40 instead of $170. And then we can cancel out answer choice 3 because once again equals 40, not $170. Now we're in between answer choices 2 and 4, but we need to think about that 40 and where that comes in. So we have 40 plants, but if we take away those daffodils, which is similar to the both, we know that we're left with the price of the tulips along with whatever else that the daffodils are. But the only one that follows the order of what we stated up here would be answer choice 2. So the correct answer would be 2. So determining that 40 minus D isn't as important as knowing what your total is. and also how to set up this first initial part of your equation. Question 10. So a function is defined as h of x equals x squared minus 3x plus 1. What is the value of h of negative 1? This is a beautiful problem. It's a question that most students should get correct, if not all, because all we have to do is substitute negative 1 for x. So our first way of rewriting this would be h of negative 1 equals negative 1. Make sure you put in parentheses, especially if it's a negative, minus 3 times negative 1 plus 1. So now h of negative 1 equals negative 1 squared is 1, plus 3, because negative 3 times negative 1 is positive 3, plus 1. And this simplifies to 5. So our correct answer here will be answer choice 4. Question 11. The zeros of p of x equals x parentheses 3x plus 2 close parentheses, open parentheses, x minus 5 close parentheses are. In a problem like this, we want to split up our expression into 3 parts that can be made into 3 equations. So we have x, 3x plus 2, and then x minus 5. So each time that we're multiplying, we're going to separate that into a new equation. So we should have 3 equations here, which means that we may have 3 answers, but we'll see at the end. For this first one, we're always going to, if we're asking about zeros, we're going to set it equal to 0. So x equals 0. That's already done for us. So we know we need an answer choice that has 0 in it. The only 2 that have answer choices with 0 in it are 3 and 4, so we can automatically cancel out 1 and 2. Next up, we have 3x plus 2 equals 0. You're going to subtract 2 from both sides. So you're left with 3x equals negative 2. And now we need to divide both sides by 3. So then x equals negative 2/3. The only one that has negative 2/3 is answer choice 3. But let's just double check just to be sure we didn't make any mistakes. So we have x minus 5, and we're going to set that equal to our lovely 0 once again, which means that x equals 5, because the only value that we can put in for x is 5 minus 5 to get us to 0. So 3 would be our correct answer. Ooh. Not bad. Okay. Question numero 12. So we have, if f of x equals 1.25 raised to the power of x and g of x equals 3x plus 10, what is the smallest positive integer of x for which f of x is greater than g of x? In these cases, once again, we're going to plug in these lovely answer choices, because why would we do extra work if we don't have to? So let's start with answer choice number 1. So we have 18. So we have 1.25 raised to the power of 18. And we want that to be greater than g of x, which is 3 times 18 plus 10. I don't know what 1 raised to the power of 18 is off the top of my head, so we're going to use our handy dandy calculator, which you should be supplied on the day of your test. So we have, let's clear it out, 1.25, and then we're going to use that caret button to raise to the power of 18, and then hit enter. We get 55.5. And we want to see if that's greater than 3 times 18 plus 10. Once again, we can plug that into our calculator just to make it easier for us, because why do the work if you don't have to? We can save that time. So 3 times 18 and then plus 10, we get 64. 55.5 is not greater than 64. So answer choice 1 would not be true. Get into answer choice 2. So 1.25 raised to the power of 19 is greater than 3 times 19 plus 10. Do the same thing. 1 raised to the power of 25, or 1.25 raised to the power of 19. And then that caret button, 19. We got 69.39. If we round to the nearest hundreds, Oh, we want to see if that is equal than 3 times 19 plus 10. And that equals 67. 69.39 is greater than 67, so this answer would be true. You can also go in and plug those two values in. I'm too lazy to do that, I'm not going to lie, so we're not going to do that because we already figured out what the answer is. And I know for a fact that my answer is wrong. I'm playing, my answer is right. Okay, question number 13. We have, what is an equation of the line that passes through the point 2, 5 and -2, -1? So you guys started learning this in Algebra 1. You're also going to learn this in geometry if you take geometry next year or after 1 Regents. You're going to use it for equations of circles, and it usually comes up on the Regents once or twice depending. But if we know that we're given 2 points, we always want to use that slope formula, which would be y2 minus y1 over x2 minus x1, and that equals m, which is our slope. So we have y2, which is -1, minus y1, which is 5, all over x2, which is -2, minus 2x1. That simplifies to -1 minus 5, which is -6, and then -2 minus 2, which is -4. This needs to be simplified all the way. Since we're doing a negative divided by negative, we know that our answer is going to be positive, and the only value that goes into 6 and 4 equally is 2, so we're going to divide both by 2, which leaves us with 2/3 as our slope. Sorry, 3/2 as our slope. So we can cancel out answer choice is 3, and we can cancel out answer choice 1. When your equation is written like this, it's written in the form of y minus k equals m, and then parentheses x minus h. H is typically your x value in your expressions, like it would be the center point, which would be hk. So whatever your x value is gets plugged in for h, and whatever your y value is gets plugged in for k. And then m, of course, is our slope. So we're just replacing our slope with 3/2. We're going to use one of the points given to us, and it looks like they use the first point. So we have x minus h, and h is going to be 2, and then k is going to be 5. So we're going to do x minus 2, and then y minus 5. The only one that matches that would be answer choice 2. The order does matter, and a lot of students will get mixed up and say y minus 2, x minus 5. You want to be careful and make sure that those x values stay with the x values. So x with x, sorry, y with y, x with x. Okay, 14. At a local high school, students were asked to name the sport they like to watch the most. The results are summarized in the table below. So we have football, basketball, and baseball with male and female players. Approximately what percentage of female high school students prefer to watch basketball? We're asking about percentages, which is a key part because we know that we need to have a fraction and multiply that by 100. So it's typically going to be your part over your whole, which you learned in 7th grade, and then we multiply that by 100. And we want to figure out female students, and specifically that watch basketball. Those are our key parts. So our part is going to be the females that watch basketball. And then our whole is going to be the total students watching every sport. Sorry, not total students, total females. So when we set up this fraction, we know for basketball, the females is 40, and then we want to add the total of all the females as well. So we're going to put 40 over 20 plus 40 plus 10. So the females who prefer to watch football, the females that prefer to watch basketball, and the females that prefer to watch baseball. So 40, we're going to put over 20 plus 40, which is 60, plus 10, which is 70. And we know that the zeros cancel out, so now we have 4 over 7 But as a reminder, we need to multiply that by 100. So right now we got 400 over 7, which simplifies down to 57%. You could also put that into the calculator. So the actual equation we will be typing in is 40 over 70 times 100, and that will give us our percent. Question 15. An equation that yields the same solution as x squared minus 10x minus 24 equals 0. So this one, we are completing the square. Once again, this is something that you're actually going to learn in geometry as well when you're working with circles once again. So we have x squared minus 10x plus 24 equals 0. We want to move that constant term over to the right side of our equation. That's always going to be our first step. So we have x squared minus 10x plus 24, minus 24 equals 0. So first things first, we're going to add 24 to both sides to move that 24 on over. For some reason, my brain is saying different things to my hand. So we're left with x squared minus 10x equals 24. To complete the square, we need to finish our binomial. So we have x squared minus 10x, and we want to turn that into a trinomial. So we're going to have x squared minus 10x plus some value. Since we're adding a term into our equation, we also have to do the same thing on the other side to keep it equivalent and balanced. So whatever that term is that we're adding to the left side, we also need to add to the right side. In order to do this, what I like to do is take our second term, so negative 10x. I'm going to take that negative 10, divide it by 2, and then square it. So we're taking the value of b over 2, and then we're squaring that. And that gives us our third term. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So that's what's going to go in our blank here. And whatever we put on one side, we have to do on the other. 24 plus 25 simplifies down to 49. And then now we just need to simplify this as a squared binomial, which will be x. Since it's negative 10, we know that our value is going to be negative 5. And then square that buddy. So the only answer choice that matches will be answer choice number 4. If you ever get confused with completing the square, you can also use a different formula if you'd like. It does not have to stay that way. There's sometimes where it's going to be an open response question. It's going to ask you to solve completing the square, but you can use the quadratic formula. They will give you the same answer, and they're usually written in the same template, which will be ax squared plus bx plus c. So this is our ax squared, this is our bx, and this is our c. So that's another way for you to just check over your answers and see what's correct. Next up, we got question number 16. Okay, so the function f of x is shifted 3 units right and 4 units up. The result of this function is going to be either f of x minus 3 plus 4, f of x plus 3 plus 4, f of x plus 4 minus 3, or f of x minus 4 minus 3. So if we are shifting to the right, this is where a lot of times students get confused. They want to say that we're adding right, but we don't add right if we are shifting to the right. Instead, we are going to subtract to move to the right. So whatever our x value is, we're going to subtract 3. And because we're going 4 units up, that's when we use those differences and say that we're actually going positive or negative. Right and left, we do the inverse. So if it's to the right, we're going to subtract 3. And then if we're going up 4, we're going to plus 4. But this part goes in our parentheses for right or left. So we're going to have x minus 3, and then we're going to add 4 to that, which would be this beautiful answer choice. You can also plug them into your calculator instead and just type in each of these and see which one is shifting to the right and then shifting up 4 units. Question number 14. So Hannah was asked to solve a quadratic equation. Her first step is shown below. So she has x squared minus 8x equals 3, and then step 1 being x squared minus 8x plus 16 equals 3 plus 16. What property did Hannah used? Okay, so most of the time, the answers are typically the addition property of equality. Most of the time. But there are going to be times where it's not the case. So we need to figure out what is occurring between our first step and our second step. And this looks like a question that's similar to completing the square. So we ended up adding 16 to our left side of our equation to complete our square, which also means that we need to add it to the right side. Whenever you do one thing to the left that you always do to the right of your equation, that means that we're talking about equality because we want to keep it balanced, which means that our correct answer here is going to be answer choice 4 because we're adding on both sides to the addition property, and since we're doing it to both sides to keep it balanced, we want to share that equality with people. I can't just give out cookies to one person in the class and not give it out to everybody else. Addition property of equality. Okay, the data set is given below. What is the upper quartile of this data set? So the upper quartile is talking about quartile 3. You can, of course, put this into your calculator and do your 5 number summary, but I'm just going to do this out. So we need to find our median, which is the number in the middle. So first, let's figure out how many numbers we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values, which means that it is an even number, so there should be 2 numbers in the middle. And those 2 numbers in the middle, in this case, are both 32. Which means that our median is going to be the number that's in between 32, which is just 32. And that will be quartile 2, aka our median. Now we need to find quartile 3, which would be the median of our upper quartile. So we're just going to slash out until we get to that middle number. So 32 slashes out with 42, 34 slashes out with 40. So our quartile 3 is 34. You gotta be careful here because some people will choose 28. 28 will be quartile 1. So that would be our lower, the lower quartile rather than the upper. 32 is our median, so that also wouldn't be it. And then 42 is our maximum. Question number 19. So when negative 3x squared plus 7x minus 1 is subtracted from 2x squared minus 3x plus 10, the result is. Subtracted from is the key word, and you started learning this back in 6th grade, but I know a lot of people still struggle with that. Subtracted from means you're going to take that first expression and you're going to take that away from the second expression. So our second expression is going to be on top. So for example, 2x squared minus 3x plus 10. And then our first expression is going to be on the bottom, which would be negative 3x squared plus 7x minus 1. Since we are subtracting, we need to change the signs of everything that's in that bottom expression, so expression 1. So if it's positive, it's going to change to negative, and if it's negative, it's going to change to positive. So we're going to go in right now and change those on out. So this will change to plus 3, this will change to negative 7, and this will change to plus 1. And now all we have to do is combine those terms. So we have 2x squared plus 3x squared. Since those are like terms, it turns into 5x squared. And then we have negative 3x, negative 7x, which gives us negative 10x. And then 10 plus 1, which equals positive 11. The only answer choice to match with this would be answer choice number 2. For as far as I remember, subtracted from comes up quite often on the Regents. So just making sure that you put that first expression underneath the first one when you're subtracting. There's different ways you can do it. I just distribute that subtraction sign to each of those values and change those signs. So whatever it is, it's always going to be the opposite or inverse of it. Question number 20. So the value of a home in Buffalo can be modeled by the function v of t equals 96,949 times 1.0448 raised to the power of t, where v of t is the value of the house after t years. So what is the percent of increase in the values of the home each year? for this one, it's another formula that you learned back in 7th grade if you were in New York State. So we're going to use a formula of new minus the original. I'm just going to write the OG for original. And we're going to put that over our original. But when we put that over the original, we also have to make sure that we multiply it by 100. So our new is going to be, in this case, I'm just going to pick some years. So it could be any years you want. Let's say we have year 1, year 2. And these are the values of V of t. And then we have our actual function itself of what V of t equals. So we have 96,949 times 1.0448 raised to the power of t. If we were to plug in these values, so for 1 and put that into the calculator, you should get something in the range of 1,000 or 100,001, and then 292.3152. And then if we were to do the same thing with our new, so plug in 2 for t, you should have something in the realm of 210,921. So all I'm going to do is take those two values, whatever it is face value, and plug that into my calculator, taking the new, which is 2, and then our original, which is 1. So to help that make a little bit more sense, I'm going to show you how I do it in the calculator. Okay. So we have 96,949, and we're multiplying that by 1.0448. And we're raising that to the power of 2, because that's our new. We're going to do the same thing, so I'm just going to use my arrow go up to copy, and then we're going to hit enter to paste, but instead of that 2, I'm going to change that 2 to a 1 now, and hit enter. So as I stated before, we want to take our new, which is raised to the power of 2, so copy and paste that, and then subtract that by our original, and then we're going to enter. So we get 4,537. From here, we're going to take that value and we're going to divide it by our original. So our value of V1, or V when t is the power of 1. Once you do that, you're going to hit enter, and we get this lovely bad boy. This is a weird looking decimal. So once again, we need to make sure we multiply that buddy by 100. 100 just sets it to the correct percentage that needs to be. Since all of our answer choices are a percent, we want to convert it to a percent. Which we get 4.479. 4.479 rounds to 4.48, which means that our correct answer is answer choice 4. So the formula you should be using is new minus original over original times 100. Okay, question number 21. A rod is an Old English measure of distance that is equivalent to 5.5 yards. How many inches are in 2.5 rods? Okay, first thing we need to do is look at our conversion chart. So we have 1 yard equals 3 feet. But if you know, 1 foot equals 12 inches. And if you notice, we're working with inches here, which is a key part because we want to make sure that we are converting all of our answers into inches, which it doesn't give us that information. So if 1 foot is 12 inches, that also means that 3 feet is going to equal 36 inches. We're just multiplying both by 3. So our new formula here, or conversion chart, is 1 yard equals 3 feet, which also equals 36 inches. With that information now, we can go and try to scale to our 5.5 yards because we want to figure out how many inches are in 2.5 rods. So we're going to start with our yards, and then from there we can get into our rods. So we want to get from 1 yard to 5.5 yards, which means that we need to multiply by 5.5. If we multiply the 1 yard by 5.5, we need to multiply everything else by 5.5. I don't really care about the feet, so I'm just going to take the inches and multiply that by 5.5, and then from there we get 198 inches. For the feet, just in case you wanted to know, it's 16.5 feet. And we know that a rod is 5.5 yards. So 1 rod equals 5.5 yards, which means that this would equal 1 rod. We want to find how many inches are in 2.5 rods. So now we need to increase each of these values by 2.5 rods. Well, not necessarily, just the inches. So 198 times 2.5 should get us 495 inches. So our correct answer here would be answer choice 4. You gotta be careful and make sure that you're reading carefully to notice when it wants you to convert. I don't know why the Regents is like this, but they do it quite often where they just want to trick kids into picking the answer where they're not reading properly. Let's move on. So we're almost done with multiple choice, just a couple more questions left. So when solving the equation 2x squared minus 3x minus 6 equals 0, using the quadratic formula, the solutions are... So quadratic formula is always given to you on your reference sheet, which is negative b plus minus square roots of b squared minus 4ac all over 2a. At some point in your life, you might just have this formula memorized for no reason. You never know. But we need to identify now the values of a, b, and c. So this is a, b, c. So a equals 2. B equals negative 3, because there's that subtraction sign in front. And then c equals negative 6. Once again, having that subtraction sign. So now all we have to do is plug these bad boys in. So we have negative b, or the opposite of b. So we can write that as negative 3 plus minus square roots, and then negative 3 squared minus 4 times 2 times negative 6. And we're going to put all of that over 2a. So 2 times 2. Negative 3 times a negative is positive 3 plus minus square root. Negative 3 squared is 9 minus 4 times 2 is negative 8 times 6 is positive 48. And put that over 4, because 2 times 2 is 4. 9 plus 48 equals 57. So now we have 3 plus minus square root of 57 all over 4. So the correct answer for this one would be answer choice number 1. As long as you identify the values of a, b, and c properly, this question can be very easy, but also make sure you're aware that quadratic formulas or completing the square almost always shows up as an open response question as well. And you're given the formula for a quadratic formula. If you know how to do the one, you can typically do the other. You might get points taken off if it were to be an open response question and it asks for you to solve using the quadratic formula and you use completing the square, or vice versa. But some points taken off versus all points, something is better than nothing sometimes. But also, get all those points if you can. Question 23. For which function is the axis of symmetry x equals negative 4? We're going to take these and we're going to put them into our handy dandy calculator, because why do all the extra work ourselves and hurt our brains on a day that we're already stressed out about if we don't have to be? All right. So we're going to clear out our calculator, go into y equals, and plug in these functions. So we have f of x equals negative x squared minus 4x minus 1. And we want to make sure that our axis of symmetry is negative 4. So where x equals negative 4. So here we can just go into our table, go up to negative 4, which is the value of negative 1. but that doesn't have the axes of symmetry. So the axes of symmetry is if we split this directly down the middle and we were to fold it over and it makes the perfect match. If you notice that axis of symmetry is actually going to be -2 because that's where that middle point meets. So let's try it again with the next one. So we have, let's clear this one out. We have negative, let me zoom out for y'all. Ooh, clear. Okay. Negative x squared plus 8x plus 5. And then we're going to graph that. For this one, you can always go back in and zoom out if you wanted to, and try to figure out if it is the axis of symmetry. But we want it to be -4, and if you notice, our graph is on the positive side, so that one can't be true. So, for example, 1 and 2 are incorrect because 1 had the axis of symmetry at -2, and then 2 has the axis of symmetry somewhere on the positive side. So let's go back in to y equals, and let's do the next one. I'm just going to clear it out. It makes it easier for my brain to focus, but if you want to just change your expression, you can do that as well. So x squared plus 8x plus 3. And then we're going to graph that buddy boy. So this one is facing upside down, but once again, we can't necessarily see her. So we're going to zoom her on out. Okay. So if we notice, and if we were to count these beautiful lines, we have 1, 2, 3, 4, -4, and that's typically where our axis of symmetry is, down here where we can't necessarily see. So answer choice 3 is a possible answer choice for an axis of symmetry where x equals -4. Let's just check it one more time with the last one and see if that's true. So we have x squared plus x minus 4. Graph that buddy boy. And as you notice, this is nowhere near -4. It's -4 on the y-axis where y equals -4, not where x equals -4. So this answer would be incorrect. So our only correct answer would be answer choice number 3. And once again, like I said, you don't need to hurt your brain over that. It'd be something quick and simple to get you through. That way you can use that energy towards other problems. And lastly, we have question 24. So we want to simplify the radical when we have the product of 2 square root of 6 and 5 square root of 3. So when we're talking about product, we're talking about multiplying. So we have 2 square root of 6 times 5 square root of 3. And a point like this, I want to split up the square root of 6. So we want to figure out those factors that can get us 6. One of the factors is 3 and 2. And I want to make sure I have one that can give me the same value of square root of 3. So we're going to rewrite this as 2 square root of 3 times square root of 2, because 3 times 2 is 6. And then we're going to multiply that buddy boy times 5 times square root of 3. Whenever you multiply a square root that has the same number underneath the root sign, why do I keep making these mistakes? A square root by the same value that has that root sign, that turns into a whole number. So that square root cancels itself out. So because we have square root of 3 and square root of 3, those two square roots of 3 will cancel out and turn into 3 wholes. So now we have 2 times 3 times square root of 2 times 5. So with that information, we just need to simplify. 2 times 3 is 6. Times square root of 2 times 5, multiply our whole numbers. 6 times 5 is 30, so we get 30 square root of 2. So 3 would be our correct answer here. And if you really and truly cannot remember this, once again, we can do this, buddy, in the calculator. So we're just going to put in 2 square root of 6 times 5 square root of 3, and then see if it equals one of these 4 answer choices. So let's do that now. Zoom out of this buddy. Okay, so we have 2 second x squared for the square root, 2 square root of 6. Make sure you do the arrow out, times 5 square root of 3, second x squared 3. And then hit enter. So we have 42.42 point yada 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 make yada. Ba-bum. Okay. So since we know that our value is in the 42 range, we also know that 1 and 2 can't be correct. So now we're in between 3 and 4. We're just going to plug in those two values to calculate and see which one equals our value that we got. So 30 square root of 2 and then 10 square root of 18. That one is the same, but let's just check with the last one. 10 second square root of 18. Okay, and if we notice, all of those look the same, don't they? That's strange. The strange part is not strange. Okay, all those are going to be the same value, but we have to remember we want it in simplest radical form, which is why 3 ends up being the correct answer. 10 and 18 can be simplified because 18 still has factors of like 9 and 2, so that can simplify to 3 and square root of 2. So 3 would be our correct answer in simplest radical form. 10 square root of 18 can also be an answer if we didn't need it in simplest radical form. Okay. If you have any questions about part 1 of our Regents review, please let me know, like, comment, share, and I will be quick to reply to you. But if you are approaching the August, June, January Regents, I wish you all good luck. I do believe you'll do well. You just need to make sure that you consistently practice. The more practice you get, the better you are going to do. So thank you for joining Burton Math Unlocked, and I'll see you on the next one.